So now let's see how we can, let's load it up. Let's see how we can take the position or transform a matrix from being represented in certain base, and we will take the trivial base and transform it to a base we want to present this matrix in. So we want this base V1, W1, W2 to be the base in which we represent the matrix A, this matrix side over here. So what we're going to do is, you'll see, we'll try to see how we can represent this matrix in this base. So we start by taking this base, and each vector we will multiply by the matrix, and then we will ask ourselves, looking on the result of the multiplication of A, for example, with V1, we ask ourselves what combination, what linear combination of the base gives you this result, and this combination will be the column of one of the columns of the result matrix A in the base of V1, W1, and W2. Okay, so these are the base V1, W1, W2 that I want to represent A in. Start with the normal base, with the elementary base, whatever you want. Okay, this A in elementary base. So we start with V1, we multiply the matrix A by V1, and we get, you can see the calculation right over here, we get minus 2, 0 for this multiplication. But minus 2, 0, it's just minus 2, 1, 1, 0. Now, 1, 1, 0 is exactly the first V1. So A V1 equals minus 2 V1. So we take this as a column, and the first value in the column is for V1. The second value is for the second vector in the base, namely for W1. And the third one is for the third vector in the base, namely for W2. Now, for V1, we have minus twice V1. For W1, we don't have anything, so 0. And for W2, again, we don't have anything, so 0. So this is one of the columns in the matrix A in the base we want. This is AV1 represented in the base we want to go to, this base, which we call capital B, okay? We continue. We take the second vector in the base we want to get to, which is W1, and we multiply A by this vector. By multiplication, we get 1, 5, 6. Now we want to ask ourselves, what linear combination, what are the coefficients, linear combination of the vectors of the base that gives you this result? Okay, so you want what linear combination give you this result? Okay, for the first coordinate, we want to take from V1 only 1. For the second, you just solve here a linear system. We ask ourselves how to solve this one. And when we solve it, we get alpha equals 1. So for V1 is 1. And beta equals 1. And gamma equals 3. So we get 1, 1, 3. For V1, we get coefficient of 1. For W1, we get a coefficient of 1. And for W2, we get a coefficient of 2. Now we put it again as a column. This is for V1. This is, this is the first one for V1, the second for W1, and the third for W3. So based on the coefficient we found, this is the representing vector of AW1 in the base we want to get to, which we'll call capital B. Okay, now for the last vector in the base we want to get to, W2, which is 0, 1, 2, we are doing AW2 in this base, and we calculate this, and we calculate this, and get this one. Now again, we ask ourselves what are coefficients for the new base that gives me this vector. Namely, I calculate this thing. When we calculate this thing, we get the coefficient alpha equal -1. So we put here in AW2 represented in the base capital B, which is the base we want to get to. The first one, the alpha, the coefficient for V1 is -1. The coefficient for W1, which is beta, equals 3. And for gamma equals 1. Of course, we just solve this linear equation. Okay? So this is the third column for the matrix in the base we want. So this is the result. We just took each one of what we got, -200 for the first column, 113 for the second column, and -131 for the third column. And this is the matrix that we went from, but represented in the vector, in the base we wanted, capital beta in this case, built from those three vectors. So you saw how we did it. I took each vector, multiplied by the matrix, and found the coefficients of the base that gives you this result. This is for each column, for each vector of the base, and we got this matrix built from these columns that represent the matrix in the new base. You can also do another thing. You can take the base, each vector of the base, put it as columns. You can see right over here, put the vector as columns. Let's call this matrix L. Now, in order to change the base, what you do, you take L to the -1, AL, you do this multiplication, and you get the transformation in the new base, the base that are the columns of L, V1, W1, W2. When you calculate this, you're getting to what we already got, just in another way, in another direction, in another option. But the same result holds, that we get this for the new base. So this was just an example on how we can take a matrix and transform it and represent it in a new base that we want it to be in. Thank you very much. And I think that's it for now. We're changing a base for representing a matrix in. Thanks for ChatGPT for writing it down neatly. And thank you all. And that's it for now.